Hey gang, Mr. Ellis here again. This time we're going to review collisions. All right, here we have a momentum versus time graph. The momentum is in standard units, kilograms times meters per second, but the time is in milliseconds. So we're going to have to keep track of that as we do some of these problems. The graph shows an interaction between two lab carts. The blue cart has a mass of 15 kilograms. The orange cart's change in velocity is 30 meters per second. So we need to draw accurate and quantitative IFFA charts that describe this interaction. Calculate the mass of the orange cart. Well, let's see here. First, let's find the change in momentum for the orange cart. So J orange is delta P. So that's final minus initial, and that's going to be 30 minus negative 30, or 60 newton seconds, or 60 kilograms meters per second. So if the orange cart has a change in velocity of 30 meters per second, can we find its mass? Well, yes, because J equals m times delta v. So that means m equals j divided by delta v. So 60, 30, 2 kilograms. Okay, so that helps. So the orange cart is way less massive than the blue cart. But notice their changes in momentum are the same amount. So the orange cart goes from negative 30 up to positive 30. So that's a change of 60. Whereas the blue cart goes from negative 30 down to negative 90. That's a change of negative 60. So momentum is still going to be conserved even though one cart is way more massive than the other. Okay, so to draw if charts, we need to find some velocities for these two objects. So let's see, let's get a chart for the orange, and then for the blue, let's see the initial velocity for the orange. Now that we know its mass, let's see, its momentum is negative 30 divided by its mass, which is 2, so it's going to be negative 15 meters per second. And its final velocity is positive 30 divided by 2, so positive 15 meters per second. For the blue, the initial velocity is going to be the momentum divided by the mass, which is 15, so it's negative 2 meters per second. The final velocity is going to be the final momentum, negative 90 divided by the mass. Let's see, that's going to be negative 6. Sure is. So negative 6. So we can see here also that even though the changes in momentum were equal and opposite, the changes in velocity were not. The orange cart, being way less massive, has a change in velocity of 15 minus negative 15, or 30 meters per second, just what we learned earlier. For the blue car, negative 6 plus 2 means it has a change in velocity of just negative 4. And those changes in velocity match the same ratio as the masses. So blue cart is 7.5 times as massive, and so its change in velocity is 7.5 times smaller. Okay. Next, we want to draw some IFFA charts. Okay, so I have my if charts set up, and we'll see if we can draw some if charts on here. So first, we have the orange small mass object going -15 here. So draw a rectangle. Let's see the orange one over here. Pretty skinny. Right here, and then we have the blue cart, way more massive, but going much slower. So let's put this over here. So really super wide, blue. Okay. So then afterwards, the orange car is going the exact same speed, but just in the opposite direction. And the blue car is going a little bit faster, but now still in the negative direction. If it's going a little bit faster, I should make this bar a little bit taller like that. Okay. So what about the force versus time graph? Well, I didn't tell you anything about a maximum force, although we do know the masses. Maybe we can figure this out here. Let's see. Because J equals 1/2 F max times T. That means F max equals 2 times J over T. So the max force is going to be 2 times the impulse. We'll calculate it for the orange cart, 60 Newton seconds. How much time does this collision last? Well, it starts at 60 milliseconds and it looks like it ends at 50 milliseconds, or excuse me, 110 milliseconds. So it means it lasts for 50 milliseconds. So 50 milliseconds. Move the decimal 3 places to the left, so that'd be 0.050 seconds. 0.050 means F max equals 2,400 newtons. All right, so now we know how tall to make these triangles, and we know how wide. Now we just make sure we get the right shape on the right side here for our force versus time graphs. Let's grab a triangle here. Let's see, does the blue one go up here? No, I don't think it does. I think the blue one goes down here. Okay, so I'm still learning OneNote here. Yes, the blue triangle's got to go down here because the change in momentum for the blue cart was negative. Alright, so then the change in momentum for the orange cart, let's see, should be exactly the same size, if I can make that work. This works about the same size. That looks pretty good. This one up here. There we go. Okay, so We know that this maximum force here is 2,400 newtons. And this force here is negative 2,400 newtons. What would the average force be? Well, the average force is the total impulse over the total time. So that's 60 over 0.05. So total time meaning just the time that the collision was occurring. Plus or minus 1,200 newtons. So an average force of 1,200 newtons, a steady force of 1,200 newtons, would produce the same changes as these spiky forces do. All right, last let's draw our velocity versus time graph. Match this up here like this. Another shape here. This. So it lasts for about the same amount of time. And always got to label this. So this is velocity in meters per second and time in milliseconds. All right, let's start with the orange cart. Let's see, maybe we should make some tick marks here. Let's see, we got to go from negative 15 to positive 15. So this should be not too bad. So boom, boom, boom. So right there will be negative 15. And boom, boom, boom. Up there will be positive 15. All right. And let's try to match this up here. So the collision starts about right there and it ends about right there. Okay, so for the orange cart, it goes from negative 15 to positive 15. So let's see. So from here over flat line, from here over flat line, you just have to connect the two with a smooth S curve, just like that. All right, I like my rainbow ink I'm using here. So for the blue cart, it goes from negative 2, which is going to be about right here, to negative 6, which is going to be about right here, in the same amount of time. So you can see that its curve is not nearly as severe as for the orange cart. Okay, I think that covers everything. Hopefully this was a good review for you. I'll talk to you later.